Hi folks, let's turn and then let's machine 6 of these Mars Curiosity Rover Replica wheels for Beatty Robotics. These are ultimately destined for a museum, which is super cool. Some really good work holding and cam here, especially 4th axis work. Welcome to another Wednesday Widget. We started with solid billet, and we had to spend some time drilling holes in here. We chose to do that because we had this on hand, but more importantly, the aluminum round tubing material was incredibly expensive. So solid billet it is. We're actually using our old Clausing 17-inch lathe here, first drilling with a 1/2 inch and then stepping up ultimately to an over 2-inch diameter drill. And this took some time, but after we got the first one done, we actually did get a flow going where we had the other ops going on the Tormach while we finished up the stock prep on the manual lathe. For those that are concerned, I assure you we will keep the lathe and manual machining content to a minimum going forward. With the holes poked through the piece of stock, we came over to Slant Pro, and it's actually relatively simple. And using our boring bar, we bored out that ID. If you're interested in learning more about Fusion 360 cam, especially on the lathe, head over to NYC CNC, click library, and if you go to cam lathe, we've got a deep dive video walking through a lot of the details and settings and preferences on ID boring in Fusion 360 cam. While we've gotten much better about breaking chips on most turning, I will admit it still plagues us on some of the ID boring stuff. Holding the stock on the outside with a 4-jaw chuck gives us full access to the ID of the part. And that's important because I wanted to finish this part in 2 ops. So once we've got the ID done, how do we then hold on to that ID to be able to turn the curve around the outside of the wheel, as well as move it over to the 4th axis and let us have full access to not only the top of the part, but also the work that we've got to do around each side. The trick is an expanding arbor or expanding mandrel. These are not only relatively easy to make, but you can make them in all different diameters and sizes, and they are an incredibly secure way to hold pieces, and they're actually also quite accurate. And the benefit here is it's going to give us full access to both the left and the right-hand side of this part. So with it on that mandrel, we're able to face it off and also turn the curve that is on the outside. We can then use that same mandrel over on the 4th axis on the Tormach. And remember last week's video when we talked about how hard milling a custom lathe tool steel bit is a really cool concept, but not necessarily the most exciting thing to watch. Same thing here. This is awesome to me. It's 4th axis work. It's for a Mars Curiosity Rover. Really cool stuff, but not necessarily the most exciting thing to watch. And I mention that because that's how we thought about this job. Was we wanted process reliability. We wanted to get this working and then not babysit it, because these were pretty long cycle times and we had to make 6 of them, so it was a set and forget. So while these were running either during the day, and we actually let quite a few of them run after hours, we were doing other stuff. That's a win. We started off with some roughing operations. This is actually just 2D contours, and what we've done is we've taken these, right-clicked, add to new folder. That puts them in this roughing folder. And we separated these out. And we did so because it's not the easiest thing in the world to go through something this complex with this many instances and select each one and get them right. So for better or worse, we just found it was easier to be able to look at them individually, walk through them. And if we had to make changes, the key is to select all of them, right-click, compare and edit, and then let's say you wanted to change the coolant. Well, you could change the coolant on everything, or you wanted to change the feed per tooth. Well, you can still do that on every op all at once. And if you're new to 4th axis, again, head over to the NYC CNC website. We've got some really good tutorials on how to do wrap tool paths as well as tool orientation. This is cool though because we are doing proper full simultaneous 4th axis tool paths to walk around this geometry. Feeds and speeds. All the RPMs we've got 10,000 to 1/8 inch tool, 20 inches per minute, which is 1/1000th of an inch feed per tooth. I know we could run this a little bit harder, but again, at this point, we were just focused on process reliability, making sure we didn't come back to broken tools. Here, under passes, we're stepping down and 40 thou increments. That's about 30% of the tool's diameter. After we finished out all the roughing or slotting them out, we came back in very similar tool path. It's just that now we're not slotting, so we're going to get better surface finishes, better chip evacuation. If you wanted to, you could even use a brand new clean, sharp tool. Side note though, we have been working on some pretty interesting slotting recipes. How do we slot reliably, get decent surface finishes, not break tools, not recut chips? So more to come on that. And other than a couple of really small tools that we had to use to clean up some corner fills, we got along great making these wheels. Again though, when you're using small tools, check your run out. We heard a rumor that the NASA Jet Propulsion Laboratory, or JPL, who made, I believe was responsible for making the rover, asked NASA if they could put the JPL initials on the wheels, and unfortunately NASA said absolutely not, we'll have no such thing. And so, again, here's the rumor, is this true or not? They put JPL in the wheels in the form of Morse code. Finally, some interpolated holes. These are how we will end up fastening the wheels to the hubs. Then we package them up, ship them off to our anodizing for a Type 2, just a regular black dye anodizing. Should make them look not only really good, but make them look a little bit more like the actual rover wheels. And that's a wrap. So stick around though. Next week we're going to walk through machining the hubs. Hope you folks learned something. Hope you enjoyed. Take care. See you next Wednesday.